So when we introduce a negative sign, what ends up happening?
You just go down.
It's going to change which direction our line is going to
Couldn't tell
go.
you.
It's opposite. Because you go down.
So yes, now in this case, we are going to go down 2 over 1. Down 2 over 1. Then we can do the same. We go up 2, left 1, up 2, and left 1. All right. So when we introduce a negative sign, our line is decreasing. All right.
Why is it on the other side?
RDD's
Negative.
Because it's negative,
Oh, okay.
right?
I don't like APEC.
This negative 2 makes it go from increasing all the way to being decreasing. All right. So we are going to see if we can use this logic with graphing linear functions to help us understand how quadratics can be changed. Let's make sure the phones are put away, please.
Cheat.
All right, so go ahead, flip it over to the next page. All right, we're gonna start by looking at what is called a parent graph. All right, so this is called a parent function or graph, okay? Parent function slash graph. And this just means there is nothing else attached to the variable that we're working with. All right, so this is gonna be y is equal to x squared. All right, that's what that first box A is saying. Y is equal to x squared. So if we want to go ahead and graph this, we're going to use the table that they have in there. So it's got -2, -1, 0, 1, and 2 for our x values.
Get it back in there.
All right. So if we plug in -2 into x squared, what is that value? -2 into x squared. What's -2 times -2? It's going to be a +4. It's going to be a +4.
Your line can't be connected.
All right. What's -1 times -1? 1. 0 times 0 is 0. 1 times 1 is 1, and 2 times 2 is 4. So now that we have x and y values, we can come back over here and we can graph what this is going to look like. So we're going to start. So we got 0, 0. We have 1 and 4, or 1, 1, 1. And then we have 2, 4. And then we can work the other way. So we have -1, 1. And -2, 4. All right, so when we go ahead and connect these points, does this look like it's going to be a line?
No, because I don't even know
No. No. So in this case, we connect them, and it's going to be rounded off at the bottom. So we connect them. We connect them. All right, and it's going to be rounded off at the bottom, and we're going to go back up in the other direction. This shape is called a parabola. It's called a parabola. Right? So when we are working with these functions today, all of them should resemble something like this. All right, so we used the table, and then we plotted the points, and then we rounded off when we graphed it. So when we look at the direction, if I'm coming down in this direction, is that increasing or decreasing?
Decrease.
That way is decreasing. All right, so that is decreasing. Which means this way is what?
Increase.
Increasing. Increasing. So you will always have an increasing side and a decreasing side. What is special about this point right here? So it's the origin, right? But what happens at this point right here?
It meets.
Use increasing and decreasing. What's happening here?
It's the lowest point.
It's the lowest point for this graph, right? So this point right here at 0, 0, 0, 0 is what we call the vertex. It's either, in this case, it is the lowest point on our parabola. Now, if I were to draw an imaginary line right here, what is that doing? Yeah, it's being an imaginary line. But what's the shape of the graph on each side of the line? It's symmetrical. It's symmetrical. Now, what would this line be? Like, if we were to write an equation for it, what would it be?
0, 0.
So it would be something is equal to
1.
0. Something is equal to 0.
1.
1 equals.
Is x equal to 0 or is
Y.
y equal to 0?
X and Y.
In this case, x is equal to 0. All right, for this line right here. This line right here, x is equal to 0. All right, and what we call this, I'm glad you used the word symmetrical here. This line, x is equal to 0, is called our axis of symmetry. Axis of symmetry. It's where the parabola gets cut in half. All right, so when we look at the parent function, it's decreasing and then it moves to increasing. If the shape is a parabola, we have a vertex, which in this case is our lowest point at 0, 0. And we have an axis of symmetry at x equal to 0. All right, so there's a lot that we can look at